I think it's time to start. So welcome in this session. I'm Guylain Pouly, working as Regional Marketing Manager for Connectivity at NXP. I'm French, as you noticed with my very poor accent. So in the next 25 to 30 minutes, we will, with you together, a new device, actually not so new, but with very innovative technologies inside, which is MCX W. And I will do a specific focus on security topic, and also a new Bluetooth feature, which is called channel sounding for localization. This is something very new, and hope this session will help you to educate a bit on this new feature. So I don't know if you are familiar with the NXP portfolio, but we have actually a very big portfolio in terms of microcontrollers and processors, from very low cost, low feature microcontrollers, who are part of the well-known LPC or Kinetis family from the past, and now we are moving to a new branding with new technologies and a new ecosystem under the brand MCX. And we will talk about MCX W series, which is a specific series inside this family, up to microprocessors with a multi-core A55 products supporting DDR memories, running Linux or Android, and so on. So we have a very big portfolio, and we can attach to this portfolio a very wide range of connectivity. So it goes from Wi-Fi to Bluetooth, Thread, Zigbee, ultra-wideband, and NFC, and so on. So we really provide flexibility in terms of architecture, performance, connectivity, and that's what makes NXP quite unique in the market today. So we can definitely address a complete BOM and address a complete system with software working on top, with certification, and also with security and additional service like a provisioning service in case you need to have your keys, secrets, and certificates programmed without investing too much in a secured infrastructure. So this is how NXP is positioned in the market. We can definitely address a complete system. So today, as I said in introduction, I would like to focus on the microcontroller part, the MCX family, which is a family of microcontroller based on Cortex Cortex core with integrated flash, with a special focus on the wireless series. So the wireless series, no surprise, is called MCX W. So W stands for wireless. So this is a family and a series of microcontroller with integrated radio. So the radio can be either BLE only or BLE plus 15.4. So 15.4 is typically Zigbee or Thread. Okay. And we, as you will see in the next few minutes, we are providing different derivatives with different size of memories, different capabilities. And on top of that, we are also offering integrated security. So this family has what we call a secure enclave, which is an isolated part of the system running its own core, its own memory. It's like let's say a simplified version of an external secure element. So inside this secure enclave, you will be able to have your secret or certificate stored. You have encrypted memories. You have a secure boot capability. You have crypto engine, RSA, ECC, and so on. So it's a complete, let's say, subsystem. I will come back on this in few minutes. And this MCX W series is part of a big family called MCX, which is sharing the same ecosystem. So same ecosystems means same format of boards. You will see it also in a few minutes. Same SDK, same development ecosystem. We have, for example, Zephyr RTOS, which is ported on all those devices. So it's part actually of a bigger family. And this slide just shows the overview of this family. So you see in light blue the MCX W series with integrated radio. But as I said, we provide flexibility and scalability. So it goes from the MCX C series in orange, running a small Cortex M0 device, very simple, very cheap actually, with some options with segment LCD, with USB as an option. So for entry-level application, or typically application which were addressed with 8-bit microcontrollers before, up to multi-core microcontrollers with dual Ethernet, with dual USB option, with multiple CAN interface, with also a neural processor unit for artificial intelligence. Okay, so we definitely address a very wide variety of application within this family. And again, all these families sharing the same ecosystem. We have pin-to-pin compatible devices, multiple package options, from small QFN or QFP devices up to BGA options with more than 100 pins. So it's a really a scalable family. So let's have a closer look now on the MCX W. So which kind of application we target? Actually, a lot of different applications, because as you will see, this device is quite versatile. So we address both industrial and IoT application. It can be commercial buildings, access control, smart homes, because also on top of that, we offer the Matter pre-certification. So we have the Matter SDK running on top of the MCX W family. This is a key market for us. Definitely, we are sitting in the board specifying the Matter, the Matter specification. So for those who are not familiar with this, Matter is the new standard for smart home, which allows interoperability between devices from different brands. So for now, with Matter compatible devices, you can buy one gateway or one hub from someone like Google, and you can make it compatible with your light bulb from another brand. So it helps to resolve the complexity of typical smart home systems. And we are really on top of that. As I said, we are a member of the Matter working group and Standard Alliance, and we provide, obviously, the Matter SDK free of charge, because Matter is royalty free on top of MCX W. So we address a lot of different applications. We address the main, let's say, technical challenges. So first, as you will see, we have a quite high performance level with this device. It's based on the MCX W is based on Cortex M33 core, running at 96 megahertz with multiple options, like the trust zone extension for security, for having a secured environment inside your system, with an MPU and with other options coming with the ARM Cortex M33 core. We have integrated RAM, integrated flash, of course, like any standard microcontroller, actually. We have an upgradable radio subsystem, and I will come back on this, because I believe it's quite important. You can design now with MCX W, and you can make sure that this device will be still compatible and supporting the next coming generation of Bluetooth standard, Zigbee standard, and so on, because it's a subsystem. I will come back on this. So security is also a key topic for this device, and I believe it's a key topic also for many customers, especially with the new CRA standard, which is coming, the European security requirement, which will be applicable for any product design and sell in the European market starting from November 2027. If I'm not mistaken, this is going to be a mandatory certification, and the whole MCX W family will be compatible with this new standard. And I will come back also quickly on the development, what we call the development experience, which is, let's say, the ecosystem. So this is the nice marketing slide, but briefly here, I would like to highlight 2-3 main information. The MCX W device is a multi-core device. Multi-core device means that you have the application processor, which is the 96 megahertz Cortex M33, as you can see at the center. This part is really dedicated to your application. We have a second core, which is dedicated for radio, and this is what we call the radio subsystem. So the radio subsystem has its own core, its own memory, own flash, own RAM, and the purpose of this subsystem is to be able to offload the application core from the execution of the stack. So the Bluetooth stack, the Zigbee stack, can be partially or completely executed out of this subsystem, which leaves free resource for your application in the application platform on the Cortex M33. And then you have a third core, as I said at the beginning, dedicated for the secure enclave. So this is what we call the edge-lock secure enclave. So this enclave, as I said, has its own core. It's a small Cortex M0+, so it's a full Cortex platform, again, running independently. And on top of that, we are providing a provisioning service, which is called EdgeLock2Go, which allows you, customers, to buy those devices already pre-programmed with your keys and certificates from NXP. Or if you want to provision your secrets in your supply chain, we have the possibility to store your keys and certificates in our own secure environment. So it's safely stored, and then you, with a cloud connection, you can retrieve your information and provision the device on your own. So this is the kind of service we are already providing today with our secure element, external devices for security, and we are now extending this service to our microcontrollers with a secure enclave. So that's the multi-core architecture, which is quite important to understand. And also we are introducing with the latest device, the MCX W72, channel sounding. I will come back on channel sounding in a second. So again, the radio subsystem is an independent system from the rest. Okay, why did we choose to have this implementation? First, because it, as I said, it allows to offload the execution of the stack inside this subsystem, and also it makes this subsystem upgradable. So today you have MCX W devices compatible with Bluetooth 5.4 or Bluetooth 5.6, but we know that in the future we'll have Bluetooth 6.1, 6.2, and so on. And we will offer the possibility to upgrade this radio subsystem to comply with the latest Bluetooth standard or Zigbee or Thread standard. So it's definitely a future-proof solution. And also, as I said, we are introducing channel sounding. So channel sounding is a new localization functionality using BLE. It's part of the latest generation of Bluetooth, the Bluetooth 6, which has been officially released back in November last year. And basically, and you will see in the next few slides, it brings more accuracy and more latency versus previous BLE-based localization methods. So as you can see in the slide, the accuracy is plus minus half a meter. From our testing, we see that we can go down to 30 centimeters. In terms of latency, it's a few hundreds of milliseconds. And it's also more robust versus man-in-the-middle attacks. You will see why in few minutes. What is making the NXP implementation unique is that we have a small DSP also embedded in the device, in the MCX W72, which is called Localization Compute Engine, or LCE. This DSP is in charge of extracting channel sounding measurements and convert it to distance data. Okay, so this one obviously definitely reduce a lot the latency, and you will see benchmarks in few minutes. And this is really a unique implementation versus what competition is doing. So you have the 3 cores plus a DSP. Okay. Ultra-wideband, you probably heard about this, and we have a portfolio of ultra-wideband UWB chipsets. So it's also a localization methodology. It's the same technology than what you have in Apple AirTags, for example. Okay. How does it compare with channel sounding? To make it short and simple, ultra-wideband is the state of the art in terms of localization. You have centimeter precision, you have few tens of milliseconds of latency, you have good, or let's say excellent robustness, because ultra-wideband is emitting between 500 megahertz to 9 gigahertz, so it's more difficult to hack. Here, channel sounding is using BLE, so only 2.4 gigahertz frequency band. So it's more robust, obviously, but it comes with a cost of an additional chipset, so it's more costly. Okay. So at the end of the day, at NXP, we provide the two solutions. You have the best solution with ultra-wideband, more costly, or you have a good solution with channel sounding, which is included in the BLE radio in the microcontroller. Just to clarify this point, I believe it's important. So as I said, there are existing methods for channel sounding based on RSSI or angle of arrival, but they were not very robust, not very accurate, and especially for the angle of arrival, it needs a complex antenna design and expensive antenna design. So channel sounding is simplifying this and also introducing this as a standard, because there were many, let's say, proprietary methods in the past. So channel sounding, as you can see in this diagram, channel sounding and measurement data are interleaved with a standard BLE data, so they are more difficult to extract, more difficult to hack. That's why channel sounding is more robust versus existing methods, especially related to man-in-the-middle attacks. So this is one of the improvement, and as I said, it's also now a standard. So it's an option of the Bluetooth 6 standard, but it's implemented in our latest device. Okay. So very briefly, I'm just a poor marketing guy, so I'm not going too much into the details. So basically, channel sounding is based on time of flight. So basically, you send a frame and you see when is it you receive the reply, and also on the round trip phase to provide a half a meter accuracy, as I mentioned previously, with few hundreds of milliseconds in terms of latency. Okay. So this is an option as part from the Bluetooth 6 version of the standard, and this standard just define how to set up and how to take the measurement, but it does not say anything on how to convert the measurements into distance. So, I mean, the interpretation or the algorithm needs to be proprietary, and at NXP we are going to provide an algorithm also with a reference design, because channel sounding needs a specific antenna design. It's not like a standard BLE application. It needs two antennas and a specific design. So we will provide the algorithm as part of an SDK free of charge, and also a reference design. So once again, we integrated a small DSP to improve the latency. So you have the numbers here. So what we did is that we performed channel sounding measurements, and we made the comparison between how, when we handle data inside the DSP or from the application processor, like what competition is doing. And as you can see, we can accelerate and reduce the latency by 45%. And again, it's really, really unique NXP implementation. So that was the latest regarding the Bluetooth standard channel sounding. We are going again to release an SDK, a specific evaluation board to have to provide the best performance. We are about to launch it. Actually, it will come next month. Clearly today there is no, to make it clear with you, today if you want to interact with a smartphone, for example, you want to design, let's say, a smart door lock, and you want to be able to open the door with your smartphone when you are approaching. So today there is no smartphone yet compatible with Bluetooth 6 in the market. It will come. For example, I believe the next generation of Galaxy phones from Samsung will be compatible. We can expect that Apple will come as well next year with the iPhone 16. I think it will be 16. I'm an Android user, so I'm not really on top of Apple products. So it will come, and definitely we see a growing interest for this technology, because at the end it will be quite cheap and quite accurate for the price. Security now, as I said, we have a very, very long history On security, we have products implemented in a lot of banking application, for example. And we are bringing this expertise into microcontroller, into the industrial and IoT market. So I already mentioned the secure enclave, which is integrated inside the MCX W series. Again, it's an independent subsystem. In terms of certification, because I know people always like to compare the market and so on. So in terms of certification and standard, the current generation of MCX W is compatible with CECIP Level 2 and PSA Level 2 certification. The next wave of products will improve, and we plan to have the compatibility with Level 3, which is the highest level. So we keep improving our offer. Once again, we are providing the edge-lock-to-go provisioning service. This is quite unique in the market for microcontrollers. This is a provisioning service. It helps you to save a lot of money if you don't have the capability and the infrastructure to securely store your certificates and secrets and to provision a device yourself in the supply chain. So this is available for any customers, not only customers who are taking us millions of units, of course, and it will be the same for the whole MCX W family. So I'm not going to spend too much time on this table. I'm not sure you can read it actually. It's quite small, but we are providing scalability. So we are providing pin-to-pin compatibility and very large software compatibility with the previous generation to help the migration. And we are providing scalability in terms of flash memory, package, RAM memory, Bluetooth support, Bluetooth standard support. And also we have since a few months now, Wi-Fi 6 microcontrollers. We've also integrated security with BLE support, with Thread and ZigBee as well. So we support scalability in terms of performance and also in terms of connectivity. The ecosystem, as I said, it's the same for the whole MCX family. So you will see a picture in the next slide of the evaluation kit. You can see this kit in the Future/NXP booth, in C19, if I remember well today. So we are sharing the same ecosystem, the same format of evaluation kit, and also the same SDK, the same also IDE. So this is what we call MCU Expresso. So MCU Expresso is an SDK with all examples, demos, and also drivers and so on. This is similar for the whole MCX family. You can retrieve it in what we call the application code hub. If you browse nxp.com, you will see links to retrieve this quite easily. In terms of IDE, so we have our own NXP IDE, which is called MCU Expresso IDE. We have an extension for VS Code. If you want to use VS Code, we are also compatible with other IDEs like AAR, for example. Zephyr is key, especially regarding connectivity when you have to deal with BLE stacks and Thread and so on. So we have Zephyr for almost the whole family. We are still working on the entry level, the MCX C family, but on the MCX W, we have the Zephyr port available. And just to come back quickly on the evaluation kit, again, we are sharing the same format of boards, and as you can see, every board from the MCX family is having Arduino or microbus headers. So in case you want to connect a sensor, a small display from those companies, we have already headers, and of course we have the software working behind. And actually we are reusing the same format of boards also for microprocessors. For the i.MX family, for those who are familiar, we are sharing the board. Obviously, it's a bit more complex because we are also adding Ethernet ports and also external Wi-Fi, Bluetooth chipsets to add more connectivity. But that's the same principle. So this is now becoming standard across the whole NXP portfolio. And again, you can see over Freedom boards in our booth today. So you can buy either the chip from us, or if you don't want to go too much into the design, we have module options. So today, for the MCX W family, our preferred option is U-Blocks. So U-Blocks, they do have a module called NINA B5, which is certified. You have several options with integrated antenna or with antenna pins, so you have multiple options. So in case you want to simplify your life, decrease the development time, you can go with U-Blocks. We have a very good relationship. They are experts in RF design, of course, and they can support you. They already have multiple customers, not only on this family but also on Wi-Fi, because they also have a wide range of modules based on our Wi-Fi chipsets. So for MCX W family, this is our preferred option. So as a summary, we still have few minutes for questions. MCX series and MCX W family in particular is definitely a future-proof and scalable family which complies with the latest generation of radio standards. So we review Bluetooth 6 and channel sounding. It also provides an excellent level of security compliant with the next coming CRA standard. Okay, with the secure enclave implementation. Okay, so definitely I encourage you to have a closer look on this one to evaluate. We have evaluation board already. The software and all the ecosystem is already public. And in case you want to discuss this a bit further, we have application engineers in our booth today, so we can have let's say a more deep conversation on a technical standpoint with our specialist. I believe that's it for me. Any question? Yes?
So ultra-wideband, I believe, can tell you which direction something is if you're looking for it. Can channel sounding do the same thing?
Yes, absolutely. Yeah. You also have the angle of arrival. Yeah, that's true. Yeah. Any other question? Yep.
Thank you. You mentioned support for Zephyr. Just curious. That's Zephyr support going forward. Are you also maintaining support for FreeRTOS?
Yes,
as well?
we keep FreeRTOS for sure. FreeRTOS is here for a very long time on our microcontroller. It's integrated in the MCU Espresso SDK. For Zephyr, it's a different philosophy. Huh? So it's a public repository. So everything we do is inside this public repository, validated by the community and what we call upstream. So it's part of the mainline to reuse Linux terms. So everything we do is public, supported by community. There is no custom implementation, or it's all supported by community. And definitely, yes, we will keep supporting FreeRTOS, but we also want to move forward on Zephyr. We are a founding member, by the way, of Zephyr, so it's a key topic for us. And I know that it's already widely used in the wireless market. Some of our competitors are already very active. So we are also on top of that. Yeah. Any other question? All right. So thank you very much for listening. In case you have any question, I'm available, and I will be also at the booth in C19. Thank you very much.